Good morning, one and all. Myself, Nagajyothi, working as an assistant professor in Department of ECE in Marri Laxman Reddy Institute of Technology and Management. So today I am here to discuss a topic called as feedback. So in the previous session, I have discussed about a basic idea of a control system, that is what is meant by a system, how can we differentiate a system with a control system, and what are the different types of control systems and examples of control systems. So basically the classification of control systems is of two types. One is open loop control system and the other one is closed loop control system. So most of the devices will work on the closed loop control system because the accuracy is more in case of closed loop control system when compared to that of the open loop control system. And the main difference between an open loop and a closed loop is, in case of an open loop there is no feedback path, but whereas in case of a closed loop control system there is a feedback path. So coming to a term called as feedback, the name itself indicates feed. Feedback consists of two things, one is feed and the other one is back. So feed itself indicates giving something, and in case of this feedback, if a system is, we are giving some input to a system and the system will give some response from that, whatever the response which we are getting, if we are giving back to the input, then it is nothing but called as a feedback. So in this session I am going to discuss about what is meant by a feedback, what are the components of a feedback, and how the feedback is going to be affected for a particular control system. So coming to this, so a feedback is a process of collecting an information about the system's output and using this information to adjust the output. So that itself indicates, in case of a feedback, just we are collecting the information how the system is going to be work. And depending upon whatever the output we are getting, as I told you that giving some part of an output towards the input is nothing but called as an feedback. So depending upon the output which we are getting, we are having a capability to adjust or to monitor to get the desired value. So some part of an output, as I am giving back towards the input, here I'll be having a capability that I can able to adjust the output as I'm giving output towards the input. That is the reason it is an example for a closed loop control system. So here, what is the need of this loop? So let me take this as a system. In this system, it consists of an input. Let me take this as X and this is output. So if I'm giving back some part of an output Y towards back to the input, this corresponding path is nothing but called as an feedback path. As it is forming it as a closed loop, that is the reason the name is called as closed loop. And what is the reason why we are using this closed loop? This loop is used to continuously monitor the output with respect towards the input, and whatever the value which we want to get as an output, that can be controlled by using this loop. So here this loop provides continuous monitoring and control to ensure that the system operates within a limit. Means whatever the output which I require, that can be outputted depending upon the parameters which we are considering for the loop. And the main aim of this feedback system is, it is used to reduce the error between the reference input signal and the system output signal. So I'll tell you what is meant by a reference input and what is meant by a output. So this is the basic idea of what is meant by a feedback and how and why we are using a feedback control system in case of a closed loop control system, and what is the reason why we are calling this system as a closed loop. As we are giving some part of an output signal back towards the input, as it is forming as a loop, that is the reason it is called as a closed loop control system. So the main, what we are having five to six main components for the feedback. The first one is a reference input, the second one is input, third is output, fourth is feedback, fifth is error detector, and the sixth one is a controller. So let me take an example of a feedback control system. Now let me take this as a generalized feedback system. As I told you that it consists of, first one is reference input. So here reference input is nothing but whatever the input or the actual input which we are getting. So here this input x of I is nothing but, I can call it as an reference input. Let me take this as a r of s reference input, and the output of this subtractor is nothing but the actual input. And the output, basically a feedback system consists of two paths. One is a forward path and the other one is a feedback path. If your input is directly going towards the output, then it is nothing but called as a forward path. If some part of an output is giving back towards the input and again making it as an output, then it is nothing but called as a feedback path. So in general, a feedback path consists of forward path as well as a feedback path. So in this block diagram, I have assumed that forward path is G and feedback path is H. As we know that in order to work the system, we need to give some sort of an input. That whatever the input which we are giving, that is nothing but a reference input. And as I told you, the main idea behind the loop is nothing but in order to reduce the error signal. So here error signal is nothing but whatever the desired value which we are expecting from a system is nothing but called as a desired output. So now let me take an example. In case of an AC, that is in case of an air conditioning, the input which we are giving is a power supply voltage which is of 230 volts and 50 hertz. But the output which we are getting from the AC is, it may be a coolness or hotness. So that itself indicates the input is an electrical energy but the output is a non-electrical energy. So here we need to convert our electrical energy into a non-electrical energy. So here whatever the reference input which I have told you is nothing but 230 volts 50 hertz supply. But as in order to work this AC, I need to give the input not a electrical quantity, it is a non-electrical quantity. So here what I'm using, I'll be using internally a transducer which will convert an one form of energy to the other form of energy. So whatever the which input which I'm giving, depending upon the old values which we are getting, that is nothing but called as an input. So the output of an error signal is nothing but called as an actual input. Before applying further error signal, whatever the signal which we are giving, or in simple words I can say that reference signal is a input signal which is given for a complete system. So for this complete system I am giving the input signal, that is nothing but called as a reference signal. But whereas input signal is a signal which is given only for a particular block is nothing but called as an input signal. So here in this case the forward path is G and the feedback path is H. This is the about what is meant by reference input or a command input, and the next one is input. So reference input is input given for the complete system. Input for whole system is nothing but called as an reference input. But this input is input given only for a specific block is nothing but called as an input. And coming to this output, in this case this x naught is nothing but called as an output. The response of a system is called as an output. And here feedback path. So the next component is a feedback path in which some part of an output signal is given back towards the input signal. So this particular path is nothing but called as an feedback path. And here error detector. So if you observe here the from the input signal, here I have represented as positive sign, and from the feedback path I have represented as a negative sign. That itself indicates this input signal is going to be subtracted from the feedback path. That is the reason here I have written it as subtraction. If I am representing this as positive as well as this as positive, then it is nothing but called as a summer. So here this error signal may be used in order to increase the input for a particular block, or in order to reduce. So depending upon the output which we are getting, if we want to increase or decrease, depending upon that, here this may be a summing point or a subtractor. So depending upon these positive and a negative signs, we can say that this closed loop control system may be a positive feedback control system or a negative feedback control system. And last, about the controller, as I have told you that in this example the input is a voltage, but the output, let me take which I want to get the output as 70 degrees centigrade. So the desired output is 17 degrees centigrade, but whatever the reference input which I am giving, either it may be a 30 degrees, that is it may be a room temperature. So whenever I am switching on an AC, the input will be generally a room temperature, but whatever the output which I required is, I required only 17 degrees. So this 30 degrees need to be reduced towards the 17 degrees. That is the reason here I'll be using a subtractor. And as I told you that the input for an AC is voltage, but output is cool. That is the reason I need to use a transducer in order to convert a one form of energy into the other form of energy. And as I am controlling, means I want to change the temperature from 30 to 17 degrees. That is the reason I need to have a controller which will give you the information that the output is controlled in terms of its input parameters, is nothing but called as a controller. So basically we'll be having the main components of a feedback is reference input or a command input, input, output, feedback path, error detector, and a controller. So these are the basic components of a controller. So depending upon this, as I told you that this is a reference input. So for this block diagram, reference input is Xi and actual input is the output of a subtractor, and this is an output parameter, and there is a feedback path which is having a gain A and a forward path which is having a gain A. Here for everything in this, we need to first derive a function called as a transfer function. So before going for that, first let me tell you what is meant by a transfer function. So a transfer function is a ratio of Laplace transform of output towards the Laplace transform of input, assuming the initial conditions are 0. So here transfer function can be written as Laplace transform of output by Laplace transform of input, and I'm assuming the initial conditions is equivalent to 0. So if you observe this system, the output of this system is x0 and the input for this system is xi. So here for this system, the transfer function is nothing but x0 of s, here s represents in Laplace domain, and xi of s. So that is output by input in terms of Laplace domain, and assuming the initial conditions is equivalent to 0. So now let me take this example of a feedback system and let me derive an expression for the transfer function. Now if you observe here, as I told you that I am feeding back some part of an output signal towards the input. So here output is x0 and the feedback path gain is b. That is the reason the output of a feedback path is given as b into x0, that is gain into some part of an output signal. And if you observe here, let me take this as a parameter y. Let me assume that the output of a subtractor is y. So here this y can be written in such a way that what are the two inputs for the y? One is input and the other one is a feedback path. So this input is nothing but xi. As I have told you, this I am using it as a subtractor. That itself indicates it is a negative sign. So minus b x0. This is the expression for which one? Input, that is nothing but where I am representing it as a y. Similarly, how can I write down the expression for x0? The output x0 is nothing but forward path gain into corresponding input. What is the corresponding input? Y. So this can be written as a into y. Substitute this y value over here. Can I say that x0 is equivalent to a into what is y? Xi minus bx0. So this can be written as x naught is equivalent to axi minus ab x naught. So if I take this term to this side, can I say it becomes x naught plus ab x naught, which is equivalent to axi. If you take x naught as common, what will be left over? 1 plus ab is equivalent to axi. As I told you that transfer function is nothing but output by input. So here output is nothing but x naught and input is nothing but xi. So the transfer function for this one is a by 1 plus ab. What is a? A is a forward path gain, and what is b? Feedback path gain. So for this one, I can represent, for this given block diagram, the transfer function is a by 1 plus ab. And please remember, here I have given a negative sign which is a subtractor, but whereas in case of a transfer function I got it as a positive sign. So this is a generalized transfer function for a given block diagram in which a forward path gain is a and a feedback path gain is b. So the same thing which I have written over here, overall gain is nothing but output by input. So whatever the thing which I have derived just now, that is nothing but a by 1 plus ab. This overall gain is nothing but transfer function. In general, gain is nothing but output by input. But what is the difference between a gain and a transfer function is, in case of gain, just we are finding out ratio of output towards the ratio of input. But whereas in case of a transfer function, we are assuming that initial conditions are 0, as well as we are applying a Laplace transform for the output as well as Laplace transform for the input. So in this expression, after getting the transfer function, we are calling this as open loop gain. A is called as an open loop gain and G is called as an overall. Instead of here G is nothing but a transfer function. So overall gain is also called as closed loop gain. So the main aim of this is, if we have given a block in which it consists of some feedback path as well as forward path, we need to calculate the transfer function for a given system. So as I've told you that we are having the transfer function can be written as, for the given block diagram, the transfer function which I got is a by 1 plus ab. So here let me assume that if ab value is negative, that itself indicates ab is negative, itself indicates ab value is less than 1. If ab value is less than 1, if it is less than 1, can I say that this becomes a by some value? So here in this situation, it becomes as a positive feedback. So if 1 plus ab is less than 1, then a particular system is called as a positive feedback system. If ab is negative, it will be giving it as a negative feedback system. So depending upon the values of a and b, it may be a positive feedback or a negative feedback. Now coming to that, as I told you that these closed loop control systems are also classified into two different ways. One is a positive feedback closed loop control system, and a negative feedback control system. Now let me assume that the first case is a negative feedback closed loop control system. So here the only difference in case of positive feedback and a negative feedback is this error signal value. As I told you that it consists of a 6 things. One is a reference or a command input. So for this system, the reference input or a command input is nothing but R of S, and the actual signal is nothing but an error signal E of S, and the output is nothing but a C of S. Similar to that of the previous case, the first thing is we need to write down the expression for the output system. So here, how can I represent the error signal E of S? It is a difference between the input signal and the feedback signal. So as I am getting the feedback from the C of S, this C of S should be multiplied with H. So error signal E of S is equivalent to R of S minus C of S into H of S. And coming to the next one, this C of S, if I want to represent in terms of a forward path gain, this is just a multiplication of this error signal with the forward path gain. So C of S is equivalent to E of S into G. Substitute this C of S expression. Let me take this is an equation 1 and this is an equation 2. Now substitute this complete E of S expression. Substitute equation 1 in the equation 2. So C of S is equivalent to G into, what is the C of S? E of S equal to R of S minus H into C of S. If you expand this, S becomes G into R of S minus G into C of S into H of S. Take this C of S term to this side. That becomes plus. So C of S plus G into H C of S becomes G into R of S. If you take in these two C of S as common, you'll be getting it as 1 plus G of H. And as you know that the transfer function is nothing but output by input. So output is nothing but C of S and the input is nothing but R of S. So here C of S by R of S becomes G by 1 plus GH. If you observe the previous one with this one, the only change is there I have kept the feed forward path gain as A and feedback path gain as B. But in this case, instead of A and B, just I have replaced that G is an open loop gain and H is a feedback gain. And please remember here, whatever the error signal which we are taking the plus from the reference input and minus from the feedback path. That is the reason it is called as a negative feedback. Means we are subtracting the reference input from the feedback signal. That is the reason it is called as a feedback. So if we are taking it as a negative feedback, the transfer in the transfer function will be having plus sign. If we take it as a positive feedback system, instead of plus you will be replacing with minus. The only difference is in case of a positive feedback system, here you will be having plus, here also you will be having plus. If it is a plus, the change is E of error signal is equivalent to R of S plus H into C of S. So that time it will be going to be changed. See here. Here in this case, both these are positive values and E of S is equivalent to R of S plus H into C of S. The procedure, whatever which we did previously is the same. Only there is a change in the sign of that. If it is both are positive, it is for positive feedback. If feedback path is negative, then it is called as a negative feedback. But whereas in case of a transfer function expression, you will be getting quite opposite. That is, positive feedback is given by G by 1 minus GH. Negative feedback is given by G by 1 plus GH. This is all about the positive feedback control system as well as a negative feedback control system transfer functions. Now, till now we have discussed about what is meant by a feedback, how can you derive a transfer function for a given feedback system. So as we have two different parameters, one is G and the other one is a H, that is open loop gain and feedback path gain. So if there is a change in the values of G and H, how it is going to be affected per a particular system. So the next is effects of feedback. So basically, whenever we are inserting a feedback in a control system, there will be a changes in basic three parameters. One is gain, second one is sensitivity, and the third one is stability. Coming to the first one, which is nothing but a gain. As we know that a gain is nothing but output by input. So whatever the block diagram in which we have seen, that we have taken it as output as C of S and input as R of S. In general, if we compare a positive feedback system with a negative feedback system is more preferable than the positive feedback system. That is the reason here I have represented a transfer function of a negative feedback system in which it is represented by G by 1 plus GH. So from this above expression, we can say that the overall gain of a negative feedback system may increase or decrease depending upon the value of GH. So, depending upon this value of GH, this gain may increase or this gain may decrease. Now, let me see how it is going to be affected. See, this is a feedback transfer function of a negative feedback control system, if this 1 plus gh parameter is greater than 1, if it is greater than 1, or in other terms gh is positive, if g, or if I say that if it is greater than 1 means, let me take this can be written as some value which is greater than 1. If denominator value is greater than 1, can I say that the gain is going to be decreased, because both are reciprocal. So if 1 plus gh is greater than 1, it is going to be affected on the gain, that is gain is going to be decreased. Similarly, if 1 plus gh is less than 1, if 1 plus gh is less than 1 itself indicates the g denominator value is less than 1, let me take g by 0.1, or let me take this g as 1 by 0.1, which is nothing but equal to 10. So if the if 1 plus gh is less than 1, gain is going to be increased. If 1 plus gh is greater than 1, gain is going to be decreased. So depending upon the values of g and h, the gain of a particular system may increase or decrease. The next parameter is sensitivity. So here the first thing is, before going for the derivation part of a sensitivity, first we must know what is meant by a sensitivity. So the name itself indicates sensitivity, means variations of output with respect to the small changes in the input. So it is a ratio between the change in the closed loop control system transfer function T to the change in the open loop gain. So here there are two things which we are considering. One is closed loop transfer function, which is represented with G T, and an open loop gain which is represented as a G. So sensitivity is represented as we are taking two parameters into the consideration. One is transfer function and the other one is gain. This can be written as percentage change in T with respect to percentage change in G. And please remember, here we are varying the parameters with the same parameter variations. That is the reason here I am writing it as dou T by dou G by G. This can be written it as dou T by dou G into G by T. So here dou represents it as a partial derivative factor. So as I have told that the transfer function of a negative feedback control system is G by 1 plus GH. So this is a transfer function for G by 1 plus GH. G by 1 plus GH. But what I require two things. One is, the first one is I need to calculate what is the dou T by dou G as well as G by T. So that is the reason this I am taking this term, this T towards this side, this becomes 1 by 1 plus GH. So this is the expression for G by T. So in the previous sensitivity factor, now I have got an expression for G by T. Along with this, I need to calculate the other more parameter dou T by dou G. So in order to perform that, as it is in the form of a U by V, so we need to apply the partial differentiation and we need to apply the formula, that is differentiation of U with respect to differentiation of V. So the formula for the differentiation of U by V is V into differentiation of U minus U into differentiation of B by V square. So here U and V, we are taking it as a terms as, here 1 plus GH is V and G is nothing but U. So as I am differentiating G with respect to G, this is 1, and minus U is nothing but G, and differentiation of 1 plus GH will give you 1. So this becomes 1 plus GH into 1 is 1 minus GH by 1 plus GH whole square. This GH and this GH will be cancelled out. So differentiation with respect to 1 plus GH into G is nothing but 1 plus GH whole square. Now I got an expression for dou T by dou G as well as G by T. Dou T by dou G is nothing but 1 plus GH whole square and G by T is nothing but 1 plus GH. So substitute those values so that you will be getting the sensitivity of a negative feedback control system is 1 by 1 plus GH. So even if you observe this sensitivity parameter is also depends upon the 1 plus GH value. So depending upon this 1 plus GH value, similar to the previous case, this sensitivity may be increased or decreased. So the gain as well as sensitivity parameter of a feedback depends upon the 1 plus GH value. If 1 plus GH is more, gain and sensitivity will be less. If 1 plus GH will be less, gain and sensitivity will be more. And the last parameter is effects of stability. So before going further stability, the first thing is when we can say a particular system is a stable system. So we can define a stable system in different parameters. Let me take an example as, if I am giving a bounded input, means a measurable input, and the output of a system which I am getting is also measurable output. So a system consists of bounded input and a bounded output, then such a system is nothing but called as a stable system. Now let me take an example in which a signal, it is continuously varying with respect to time and it is continuously increasing, means as time is increasing, as time tends to infinity, this amplitude also going to be changed, means I cannot able to measure what is the amplitude at t is equivalent to infinity. So this is an example of an unbounded system, means if you are able to measure the input as well as output of a system, then only such a systems are called as an stable system. So a system is said to be stable if its output is under control, means if we are able to measure the output of a system, then only we can say it as a stable system. If we are unable to measure the output of a system, then it is nothing but called as an unstable system. So same thing, we have in all the three cases, we are taking a simple transfer function formula of a negative feedback system, that is G by 1 plus GH. Now let me take in this case, if GH value is equivalent to -1, if GH is equivalent to -1, can I say the denominator part is going to be 0? If this denominator part is going to be 0, can I say the transfer function is equivalent to infinity? Means if the denominator value GH is equivalent to -1, the output of a control system will be infinite, then the system becomes into an unstable system. So depending upon the feedback path which we are taking, that will decide whether the system output may be a stable system or an unstable system. So this is all about what is meant by a feedback, what are the different components of a feedback, what are the different types of feedback systems in case of closed loop control system, and what are its effects. Thank you.